Hello and welcome to another video about set theory. In this video we're going to do another natural language aside now that we have some different properties that we can talk about with regard to different relations. So in our last little natural language aside about relations, we established that the meaning of the word like, right, so it's in these little brackets, which means the meaning of the word like is that there is a set of pairs of things x, y, such that x likes y, right? So for example, this is a set of pairs like Ravi likes running, Melody likes cheese, so on and so forth. If you feed it to an x and a y and that pair is not in there, it's gonna, tell you that that's not a member of that set, and so that relation is not true between those two different items. So in this video, we're going to start looking at whether the individual properties that we've talked about for different relations hold true for given lexical relations. So this relation like, is it true that like is a function relation? So we think about this, is it possible for somebody to like more than one thing, right? Can one member of the domain be related to two members of the range? Yes, that it can be, so it is not a function. It is totally possible for Ravi to like both running and cheese, so it's not a function. Is it reflexive? So if it were a reflexive relation, then everyone would have to like themselves. In an ideal world, this would be true, but I think it's pretty clearly not the case, sadly enough, that everyone likes themselves, so this is not a reflexive relation. Is it symmetric? So if it was symmetric, then if Ravi liked Melody, then Melody would have to like Ravi. Unfortunately, we do not live in such a world where liking somebody or something immediately guarantees that it likes you. I mean, you can even think of Melody likes cheese. Does that mean that cheese likes Melody? No, cheese can't like anything, right? So this is definitely not a symmetric relation. Is it a transitive relation? So if it were transitive, what would this look like? This would mean that if Ravi likes Melody and Melody likes cheese, that Ravi would immediately like cheese. This is definitely not true. You can tell, anybody has had an experience where somebody that you like or something that you like something that you don't like. My cat likes to eat cat food and I don't like to eat cat food, but that doesn't mean I don't like my cat, right? So this is, so this particular relation like has none of these traits. It's not a function, it's not reflexive, it's not symmetric, it's not transitive. So what is the meaning of the word no? It is a set of pairs such that X knows Y, right? That's fairly simple. It looks just like this in terms of, how we would represent it in set builder notation, right? Now we look at this one. Is this a function? Is it possible to know more than one person or thing? Yes, it definitely is. So this is not a function, right? Ravi might know about running and know Melody, and that's totally fine. You can definitely know more than one thing. Is it reflexive? If this is the case, then everyone knows themselves. I would say this is true. We could get philosophical about it and talk about what does it really mean to know yourself. But if we take the most basic meaning of know, that it just means like you're familiar with, you would recognize, you have some sort of familiarity with yourself, then that is true. Everyone knows themselves, so this is a reflexive relation. Is it symmetric? If Ravi knows Melody, does Melody know Ravi? Not if Ravi is spying on Melody. So we're going to say no. Right? So it is possible for one person to know another, but the other person doesn't, it doesn't go both ways necessarily. This often is symmetric, but it's not necessarily symmetric. Is it transitive? So if Ravi knows Melody and Melody knows Beulah, does Ravi know Beulah? No, not at all. There is no no implication that that's the case. So this is so these two relations, when we look at them written out like this, they look very similar. All that we're changing is this part, right? Likes versus knows. But this has changed, right? So just because we have a different word in here, even though they're sort of combining with nouns in the same way, they're doing the same thing, they're both two-place predicates, they're both combining in the same way, one of them has a trait that another one does not. So we'll come back to this in a minute. We're going to go through a couple more of these examples. So we already talked briefly about the word is married to in the last video, but now we're going to talk about the verb marry. So what does it mean to marry? What does this verb mean, right? We're talking about a set of pairs of things, X and Y, such that X marries Y. And this is again the same kind of structure as we've seen for other two-place predicates, right? So we ask ourselves, is marry a function? Is it possible to marry more than one person? Yes, it is. So it is not a function. You're not supposed to be married to more than one person at a time, but you can marry more than one person in your lifetime, so it's not a function. Is it reflexive? Do you marry yourself? It is actually impossible to marry yourself. So this is something that we haven't seen before, that it's impossible to marry yourself. You can like yourself, you can know yourself, you can't marry yourself. Is it symmetric? This would mean that if Ravi marries Melody, that Melody marries Ravi. This is true. It is symmetric. You can't marry somebody without them also marrying you. Is it transitive? So if Ravi marries Melody and then, I don't know, somehow Melody later in her life marries Beulah, is it allowed that, do we assume that Ravi has married Beulah? No, not at all. That is not transitive. I guess it could be transitive if people are getting a lot of divorces. And, marrying each other's exes. That would be sort of an unpleasant situation, but you could imagine that you could have a transitive relationship, but it is not necessarily transitive for sure. So here we have two things going on that we might want to come back and revisit, right? So this is symmetric, and it can't be reflexive. We're not going to talk about the difference between non-reflexive and irreflexive in this class because it's not that different. But it can't be reflexive. So this is an interesting fact about this. All right, one more, and then we'll talk about how we deal with these. We have this relation better than. So this isn't really a verb, but we can talk about it as a two-place predicate, right? So we have a set of pairs of things, X and Y, such that X is better than Y, right? Is this a function? Can X be better? Can Ravi be better than Melody and also better than Beulah? Yes, definitely. So no, this is not a function. Is it reflexive? Can you be better than yourself? And unless we're talking really philosophically, no, you can't be. Right? Is it symmetric? If Ravi is better than Melody, is Melody also better than Ravi? Can't be. Right? It can't be the case. This is a one-directional relation. It cannot be symmetric. Is it transitive? If Ravi is better than Melody and Melody is better than Beulah, is Ravi better than Beulah? Yes. This is definitely a transitive relation. So we have all these things with this relation that are really different, even though the combination of this basically looks the same. So this tells us that we have to, when we assess the meaning of something, we have to assess sort of at two different levels, right? So the first level is it a two-place predicate? Or a one-place? Or a three-place? Right? So this is how we assess, how many arguments it takes. That's what we call these in linguistics, is argument, right? So do we have a single thing? Do we have an ordered pair? Do we have an ordered triplet? Things like that. But we also have to talk about these kind of restrictions that they place on what they can take as their arguments. So we have two divisions of semantics that come out of this. So the first is compositional semantics, which cares about how the word meanings combine, which is one place, two place, etc. Where we're not really caring about what is the word in here, right? We don't really care that much about what is the word in there. We only care about what this set looks like, what this relation looks like. And the other one is lexical semantics, where we really do care about the word because it's going to influence what can and must be connected in that relation. So this tells us about two different areas of semantics, and this is a wonderful reason why it's important to look at relations and the mathematics of language. So thank you for watching this video.